Have you ever broken something that isn't easily replaceable? Or something that you needed right now? As nice as plastic can be, it is far from indestructible. Picture this scenario. Your nephew's first birthday starts in 10 minutes. It's Sunday, everything closed. Your only job was to bring the candles. But the one you bought fell from the table and broke in 2 pieces. What do? Well, worry not, my dear friend. Your nephew's party will be safe with the Plastic Sculptor. And this is it. And you might be thinking, but this is just an old crappy soldering iron with a pretty out of shape tip actually. And that is exactly what it is. However, it has proven to be quite useful for repairing, joining and cutting any plastic part you can think of, as long as it's a thermoplastic. Making this device is actually quite easy. You can take pretty much any soldering iron, preferably a cheap one since you're going to destroy it, and then file the tip of the soldering iron into any desired shape. An all-rounder style that I found works pretty nicely is this bent knife edge shape with a pointy tip that helps you pierce through plastic. So let's see how it works. Here I've got a solid bowl with a pretty severe crack. In order to fix the crack, you have to first melt the plastic. A technique I found to work quite nicely is to melt all the way through the crack as if you were trying to actually open it, and then scoop up the molten plastic you have displaced back into the gap you have created. This way, all the surrounding plastic is molten and the joint is strong. We repeat this process until the crack is completely sealed. I must warn that this process tends to leave a rough texture on the surface of the plastic. However, it can be easily sanded down afterwards. As you can see, the joint can be as strong as the original plastic. On one of my first adventures with the Plastic Sculptor, I tried to fix my refrigerator shelf. You can see that the result is remarkably strong. And yeah, I know, it is as ugly as it can be. But you know what they say. You do not look a gift horse in the mouth, especially when it's holding your milk and your gazpacho. Surprisingly, the world of thermoplastics is not limited to rigid materials. I found out these pliers handles were actually made out of a thermoplastic. Their main problem is that with use, the handle comes out the end, exposing the metal part and preventing you from working comfortably. Nothing that a little melting cannot fix. You can see they're squishy and resistant like the first time. Okay, now back to the candle. Even though candle wax is not technically a thermoplastic, it can be molten, so it can be fixed. One particularly annoying point about these candles is that they are not 100% wax. They contain quite a significant amount of air inside, and when you melt them, the molten zone becomes somewhat dimpled. Even though it's not completely necessary, you can fill in that dimple with some regular candle wax. I'm quite surprised of the result. It's really strong, probably stronger than the original, and the repair marks are quite subtle. Another interesting use of the Plastic Sculptor is to reinforce already existing 3D prints. You can see this 3D print had a layer adhesion problem, and even though I tried to touch it up with a 3D pen, it didn't quite achieve the strength that was needed. However, by flattening down the added material, the resulting 3D print turned out to be astonishingly strong, saving me 3D printing time and material. Still on the subject of repairs, I tend to overload my 3D prints. However, I strongly dislike wasting material. That's why I always try to repair my 3D prints. And a surprising secondary effect of repairing 3D prints is that, if done right, the repaired part can actually be stronger than the original 3D print. That is due to the fact that you're remelting the layers, so they end up strongly bonded together. no material goes to waste. You can see how much stronger the 3D print has become. If you're crafty enough, you can even repair delicate things, like this cooling fan's fin. Another interesting use of the Plastic Sculptor is to embed things within 3D prints, as I demonstrated on a previous video. Arguably, one of its most disruptive uses is to join 3D printed parts that would benefit greatly from being printed separately. Like for example these two parts, where printing them together would have meant to add a lot of support material, and the surface quality would have been greatly affected. In order to join the parts, we only need to melt the area of the joint. As you can see, the resulting piece is significantly stronger and aesthetically more pleasing than if it had been 3D printed as one piece. However, my current Plastic Sculptor has somewhat of a limitation. Since its temperature cannot be regulated, the plastic that remains on the tip is burnt after a while, and if we do not clean it every time, the part we are working on becomes stained with burnt plastic. Luckily for us, this has an easy solution. We just need to make sure that we buy a temperature regulable soldering iron, which of course are equally cheap. Keeping the Plastic Sculptor at a temperature of 200 degrees will prevent the plastic from burning. Until then, I'll have to brush off the burnt plastic every time. The final use that I found for the Plastic Sculptor is to trim and cut. For example, this 3D print was slightly oversized, so instead of discarding it, I just quickly trimmed it out to size. Another example is this syringe that I needed to cut open. The plastic was too strong to be cut with a utility knife, but with the Plastic Sculptor, it cut through like butter. One of the main advantages of this method is that the edges that the Plastic Sculptor creates are already soft to the touch and they do not need to be filed down. Alright, bye! You too, my son.